Looking at number 10, we have a table showing value of a car based on the number of miles it's been driven. So we have our x values are miles driven, y values is the value. And we know here based on the question that this is a linear best fit model. So I'm going to start first, before we attack the question, I'm going to start with entering in the table. Go to the plus sign, add a table. 4,000, 9,000, 15,000, 20, 28, 35, 40, 800. Now, I'm looking for the points over here, and I can't see them because these are really, 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 really big numbers. So I'm just going to keep zooming out. And now I've found my numbers. They're going down, and it's pretty close to a straight line. And we're going to find the equation of the line of best fit, and it will put the line through there. But we're wanting to know what is the approximate correlation coefficient. Now, what is a correlation coefficient? The value of the correlation coefficient, first of all of these are negative, so we can't eliminate anything yet because the dots are going downhill, so that means it's negative. That's the only part so far that we know and can identify. If it's negative, the dots should be going downhill. If it's positive, they'd be going uphill. But this correlation coefficient tells you how close or how strong of a relationship would our line of best fit be if we created this equation in line of best fit. I'm going to go ahead and do that just for extra practice. Y1 tilde mx1 plus b. And here's our line. And we see that it's pretty close. Okay? Now, there are two ways where you can find the line of best fit. First, it's this value right here. If you remember this equation, the correlation coefficient is the R value. It's at negative 0.967. So it looks like it's closest right here to negative 0.97. However, I will say this. That number is negative because they're downhill, but this number is really close to the whole number 1. The closer to the line the dots are, the closer this correlation coefficient number will be to the whole number 1. Now, it can be -1. Negative, remember, tells you that it's going downhill, so that's okay. But the closer it is to -1, the tighter or the closer the points are to the line. If the correlation coefficient had been like a 0.5 or a 0.6, the dots would have been a lot more scattered. However, let's say you forgot this and you needed another method to do this. If you can, we'll get rid of this. And I'm going to go here, and it says correlation coefficient. DESMOS will do this for you. I'm going to type the letters CO. Now, so far it hasn't recognized anything, and it's in italics. But when I go RR, this is for correlation coefficient. And all I have to do is put in parentheses x1, comma, y1. And there's my answer. Correlation, CORR, x1, this, and this. And actually, it doesn't even matter if this was y1, x1. It doesn't matter the order. It takes the correlation coefficient for you. And again, that was the same answer as before, the negative 9.7. So either way should work to get your correlation coefficient.